Hello, today let me walk you through valid parentheses. Parentheses.
Parenthesis.
Parentheses. Parentheses. So this is the stack topic, very classic problem. So let's check problem sentence. You are given a string S considering of the following characters, them. The input string S is valid if and only if this condition. Every open bracket is closed by the same type of close bracket. Open brackets are closed in the correct order. Every close bracket has a corresponding open bracket of the same type. Okay, first, let's imagine interviewer and we are candidate. So let's question. First of all, how can we call these characters? Like this, like this, like this, like this, like this. Parenthesis, curly brace, bracket. So this is open parenthesis and this is close parenthesis. And open curly brace, close curly brace, open square bracket, close square bracket. Can I call this? Can I call this 2 is bracket and this 2 is curly brace. This 2 is paren. Next question. Does string S contain other characters? Nothing. S contains these parentheses, curly brace, square bracket only. Okay. So let's make happy case. S is open bracket and close bracket. It's true. Second case. Open paren and open bracket and open curly brace and close curly brace, close bracket, close paren. It's true. And fourth case. Open bracket and open bracket. This is false. And open paren, open bracket, and close curly brace, close bracket, close paren. This is false. And S is open bracket, close bracket, open bracket, close bracket. This is true. An edge case. S is empty. The length of S is more than one character. And constraints is starting at 1 and string S length is until 1000. Okay. So let's make plan. First of all, brute force. I like orange pen. Let's think about brute force. First, imagine example. true case. Example 1. Open bracket and open curly brace and no, open mm, open curly brace and open paren and open bracket, close bracket, close paren, close curly brace. This is true. Why? Because we can remove first. We remove this result. This. And next, we can remove this. And then this. And finally, we can remove this. And last, empty. So this is true. And example 2, this is false case. For example, parents and I forgot curly brace. Yeah, curly brace and close bracket, close parent. And we can't remove any bracket pairs. So this is invalid and this is false. So in the brute force case, we iterate every characters of S until S contain these pairs and removing the pair of every brackets. If the string becomes empty, this is valid, like this. But if remaining, this is invalid. So, you know what? Every search of brackets works in every search of brackets works in big O n time complexity because we look up each characters. We look up each characters. And if worst case, so imagine this. Imagine this. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This is worst case. Uh, if possible, this. うん。あうん。maximum is 1000. うん。We remove parentheses in n over 2 times. Why? Because first we remove this. So this is remove. And next we remove this. So this is remove. And next is here. Next is here. So this this operation is n over 2 times. This is the number of loops. Actually, total time complexity is this n over 2 times n, because we iterate no. We iterate n over 2 times, and this removing operation takes n big O n linear time. So total n square time complexity. Okay, pseudocode is pseudocode is here. Mm. While loop until string S contains this or bracket pair or curly brace pair. While loop and replace this pair with empty and replace bracket, replace curly brace. If S is empty, return true. Otherwise, return false. This is pseudocode. Okay, how about another approach? Another approach is stack. Valid parentheses must follow a last opened, first closed order. What's mean? Last opened, first closed order. Last closed, first open order. What's mean? I'll walk you through more simply. Let's say this example. First character is this. This is opened. And next character is this. This is also open. And next character is this. Yeah, this is also open. And this is closes the last opened this. So this is close the last open this. And this is closes last open this. So last open and first close. This is exactly how a stack works. If we hear this, we can use stack. We use a stack to track opening brackets. To track opening bracket. Whenever we see a closing bracket, we simply check whether it matches the most recent opening bracket on the top of stack. If it matches, we remove that opening bracket. If it doesn't match or the stack is empty, the string is invalid. A valid string ends with an empty stack. So we check the top of stack and check if it is match a corresponding of closing bracket. Okay, let's pseudo code. First, create stack to store opening brackets. And we iterate every character of S. If it is an opening bracket, opening bracket, push it onto the stack. If it is a closing bracket, check if the stack is not empty and it's loop. No, it's top. And match, TCH matches the corresponding opening bracket. If yes, pop the stack. Otherwise, return false. After ending, if the stack is empty, return true. Otherwise, return false. This approach work in linear time complexity and linear time space complexity. Why? Because this iterate is only n times. And we use stack, so space complexity is also big O n time. This is time complexity, this is space complexity. So if the length of string is bigger like this, we would like to use stack approach because this is time complexity is big O linear time. But if we don't want to use unnecessary memory, brute force is better. Brute force might be used because brute force approach, this is space complexity is big O constant time because we don't use stack and unnecessary memory. As a result, either one is fine, but let's use stack approach for now. Okay, let's jump into the code. Okay, first, create stack. And we iterate every character of S for character in S. And if character is open bracket push it onto the stack. So stack dot append C, continue. If it is a closing bracket, so else if if stack is not empty and its top matches the corresponding opening bracket. If stack and stack -1, this is top of the stack, equal corresponding opening bracket. So this character is closing bracket. So we have to find corresponding opening bracket. So we can use map and in advance we have to prepare pair like this. Close bracket is key and opening bracket is value. Next, closing bracket and opening bracket. Closing bracket and opening bracket. This is the pair map. So we can check corresponding corresponding opening bracket here. If yes, pop the stack. Otherwise, return false. And last, after ending loop, if the stack is empty, return true, otherwise return false. So return stack this. Okay, that's it.